Alright, this is a video on the formula for the area of a rhombus, how to find the area of a rhombus. Okay, so before we start, we're going to look at a few things we already know about a rhombus. First thing we know about a rhombus is that all the sides are congruent. That's part of the definition of a rhombus, that all four sides are the same length, all four sides are congruent. Another thing we know, let's mark that down here, it has four congruent sides. Another thing we know is that our diagonals bisect each other. Okay, so they cut each other in half, which is important. It would be important for some of our problems because we're going to have to know how long a diagonal is, and they may only give you a piece of the diagonal, half of the diagonal, so you might have to double it in order to figure out how long the diagonal actually is. So that's an important piece of information to know. One other thing we might need to know is that our diagonals are perpendicular. And remember that upside down T means perpendicular. Okay? That will be important also. And you'll find out why in one of the examples that we do, how we could use that to our advantage in some of these problems. Okay? For our formula, we're going to need to know how long the two diagonals are. And the diagonals go from corner to corner. So I've marked D1, D2, diagonal 1, diagonal 2. Doesn't matter which one is labeled which, as long as you have both of them. And this goes all the way across the figure, so it connects one corner to the other. Our formula for the area of a rhombus is, the area is 1/2 diagonal 1 times diagonal 2. You're multiplying all those things together. Another way to think of it is my D1 times D2 over 2. That might be easier for some people, so they don't get confused with the half and distribute it all the way through. You can just multiply your diagonals together and then divide by 2. It will give you the same answer. So either one of these formulas will work. Normally when you see it written, people write it like this, but the second one here is going to give you the same answer. It does the same thing. Okay? So let's look at our examples. First example, for both of them, we're just going to determine the area. For our first example, we know two pieces of our diagonals. I'm going to go ahead and label this diagonal 1 and this diagonal 2. For diagonal 1, we know that part of it is 4. And remember that your diagonals bisect each other. This is important. Okay, so if this part of the diagonal is 4, that means D1, the whole diagonal, would be 8. It would go all the way across, and since they bisect each other, they cut each other in half, the two little chunks would be congruent. Same thing's going to happen with D2. D2, half of our diagonal is 7, so the whole diagonal would be 14. And then we can put that into our formula. The area equals, I'm going to do the problem the second way I wrote it. Multiply my two diagonals together, and then divide it by 2. So we can put that into our calculator. Well, 8 times 14, that's 112. And we're going to divide that by 2, so 112 divided by 2 would give us 56. Now there's no label on this one, so we're going to leave it generic. We're just going to say units squared, again, because we are talking about area. Alright, so pretty straightforward, but we do use that idea that the diagonals bisect each other in order to figure out the answer to this problem. Okay, our second one here. Notice we only have a piece of information for one of the diagonals. We have nothing on the second diagonal, so let's go ahead and label them D1, D2. Okay, we could go ahead and figure out D1. D1 is going to be 12, and that uses the same idea we used on our first example. We have to double 6 in order to get the whole thing. D2, we're going to use a different idea. Notice they gave us this piece of information here on the outside. They told us the sides of our rhombus are 10. Remember that our diagonals are perpendicular. This is going to be important on this problem. Okay? If they're perpendicular, if we look here, we have a right triangle that involves our 10, our 6, and then another side over here. Okay? And if we have a right triangle and we're finding a side, we could use our good friend, the Pythagorean theorem, in order to figure out the missing side. So that's what we're going to use in order to find part of diagonal 2. We're going to use our Pythagorean theorem. Okay, which is a squared plus b squared equals c squared. C, remember, is our hypotenuse, so that would be 10, and we're going to square that. And then 6 could be either a or b, it doesn't matter. So I'm going to make it a, and then b is going to be my x. That's the one we're looking for. If you want to leave it b, perfectly fine. The letter b, the variable b, that would work too. Either way, you're going to get the same answer. We would simplify this. 36 plus x squared equals 100. Take away 36. X squared equals 64. And then we square root that. So then our part of our diagonal here is 8. Now, common mistake would be, even after you've done all that work, to think that the whole diagonal would be 8. But it's not. It's only this piece, just like 6 was only part of our diagonal. So we have to double that in order to get 16. So then we have the two diagonals of our rhombus. We can multiply them together, put them into our formula. A equals 12 times 16, and we're going to divide that by 2. If we multiply 12 and 16, we end up getting 192. We're going to divide that by 2, and we would end up getting 96. Again, it doesn't have a label, so we're going to leave it generic, units squared. So in this one, a little different. We use the fact that our diagonals are perpendicular and use the Pythagorean theorem in order to figure out the other diagonal, part of the other diagonal, and then double it of our rhombus. So we're going to start combining some ideas on some of these examples. So you need to think back a little bit to some of the other things we've talked about in geometry. Last example here, a word problem. It says, if the area of a rhombus is 34 yards squared and one diagonal is 12 feet, what is the length of the other diagonal in yards? Okay, a couple things going on here. We know that the area, 34 yards squared. Now, one diagonal is 12 feet. Notice that's a different label. And then we're finding the other diagonal in yards. So we're going to do kind of what we did with our trapezoid example. We're going to work backward. And we're going to plug in what we know. This has an extra step in it that you need to be paying attention to, and we need to be paying attention to our labels, because they're not all the same in this problem. So what we want to do is change this 12 feet. Since we're looking for our final answer in yards, we're going to change this 12 feet to yards. If you think back, there are 3 feet in a yard, so we would take 12 feet, divide it by 3 feet, so that our feet cancel. 12 divided by 3 is 4, so that diagonal is 4 yards. We're going to plug what we know into our formula. D1, D2 over 2. So our area is 34 yards. D1 we'll say is 4. That's the diagonal we know. We're going to find D2, and that's over 2. All right, we can do a couple things here. I would like you to, if you're going to write it like this, get rid of the fraction. So we're going to multiply both sides by 2. 34 times 2 is 68. 68 equals 4 times diagonal 2. Then we divide both sides by 4. So diagonal 2 is, we could put this in our calculator, 68 divided by 4. It would be 17. 17 yards. Because we wanted our final answer in yards. So that's one way to do the problem. If you set up the problem, and I'll make a little spot over here to fill this in. If you set the problem up like this, which again is your preference, you would just multiply these two together. So you'd get 34 equals 1/2 times 4 times D2. So 34 equals 2D2, because half of 4 is 2. You just multiply the first two together. And then you can divide both sides by 2, and you would also get 17. You'd get the same answer. Personally, I like to do the problem this way. It seems a little easier, but it's really up to you I think the way that I've done it the first way has a little more straightforward for people, and there's fewer spots where you can make mistakes, but really it's up to you how you want to solve the problem, how good you are with your order of operations and math skills. So it's up to you. So this is our video on the formula for the area of a rhombus. So make sure that you know this formula up here, and if you have any questions, bring them to class next time.